Hello everyone. So in the last video we have seen the like rectangle related questions, largest rectangle in histogram related questions of monotonic stack. This time I wanted to cover subarray related problems using monotonic stack. I'll try to cover two questions. Uh, if you will understand first question, the second will be very easy. But this is not related to particular subarray related problems. This is actually related to from all subarray. If you find the sum of minimums of all subarray, sum of maximums of all subarrays, sum of maximum minus minimums of all subarrays. Okay. So such type of questions will cover under monotonic stack, where you have to consider every subarray and a minimum of every subarray and then do the sum of it. A sub every subarray and the maximum of those every subarrays and then have to consider the sum of those things. Such type of questions will come under this question. So let me just take the Leetcode direct question of sum of subarray minimums. Okay, so this is the question. You are given an array of integers and you need to find the sum of minimum of b, where b ranges over every subarray, every continuous subarrays of array. Since the answer may be large, we have to return it answer modulo 1e9 plus 7 or 10 raised to 9 plus 7. And here your n means the size of subarray could go until 10 raised to 4. Okay, so basically I would say the brute force complexity to find all subarrays. Now, if you have forgot what are the subarrays, let me take you an example. This is the example. Okay, then subarrays could be like 11, 1181, 1181, 94. Okay, 1181, 94, 43, or 1181, 94, 43, 3, then only 81, and then 81, 94, 81, 94, 43, dot 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 dot, dot until only 3. Okay, so these are the kind of subarrays. So brute force complexity to find all subarrays will be, we need to choose the starting point and then our ending point could go from I plus 1 or from I to n. We can take any number of elements, only 81, 81 and 94 with 11. Okay, so the brute force time complexity to find all subarrays is like order of n square. And the question says that from every subarray we have to take the minimums. So like here is the minimum 11, and then for 1181 again it's 11, for this also 11, for this also 11, for this 3, and then for only 81 it's 81, 81 94 it's again 81. So kind of those we have to take the summation and we need to return the answer. This is the summation of all minimums of every subarrays, minimums of every subarrays, and then we need to return the answer. Okay, so brute force time complexity will anyways take order of n square for all the subarrays if we do by taking two for loops. Now, how can we do this with reduced or optimal time complexity? So, can you find a way where you can see that, okay, when can 11 be the minimum? How many times? We need to find how many times array I could be minimum in how many subarrays. I could say in how many subarrays array I would be minimum. So let's say this is the example. Let me take a simple example of this 3, 1, 2, 4. So if I consider I is equal to 2. So I need to find how many times array of 2, which is what? 2. Array of 2 is here 2 is minimum. So for 3, 1, 2 it's minimum. No, 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 not. For 1, 2 it's not again. For 2 it's minimum and for 2, 4 it's minimum. Only for this two subarrays 2 is minimum. So 2 times 2 is coming as minimum. So if we find number of times array of I minimum and then we multiply that particular of array of I with the number of times it is coming minimum and then do summation of it, it becomes easy. But then the question is, how do we find number of times this particular coming number as minimum? So how did I find this two subarrays? I mean 2 with anything previous I cannot take. Why? because 1 anyways, the number exactly on the left of the 2 is minimum. So previous minimum of 2 is what? Previous minimum of 2 is what? 1. Okay. And next minimum of 2 is what? Nothing. Nothing, so minus 1. Okay. But we replace next minimum with what? Index n. We replace next minimum with n. So here basically it's 4 and this index is also 1. Value is also 1, index is also 1. So that means from I can make one subarray I could consider is like only 2 and only 2 4. Okay. So 4 minus 2, 2 subarrays I could make. 4 minus 2. How 4 minus 2? Next minimum minus I, my current element. And how many times I can make in the front, which I gonna multiply, which is I minus previous minimum of I. So here it's I is 2 minus previous minimum is 1. So total 2 times 2 is the subarray, which is 2 times my 2 is coming as minimum. Okay, let's consider for array of 1. Array of 1 is 1. So previous minimum is nothing but minus 1 because no one is previous of 1 which is lesser than 1. And next minimum is also minus 1. But as this is next minimum, we replace it with the n. So here it's 4. So your answer would be like next minimum minus I, which is 1, into previous minimum, into I minus previous minimum. So I is again 1 minus previous minimum. 4 minus 1 is 3 and 1 plus 1 is 2. So it's 6. Are there 6 subarrays where 1 is coming as minimum? Let's see. So 3 1 could be 1, 3 1 2 is 1, and 3 1 2 4 is again another, and then 1 1 2 and 1 2 4. So these are the 6 different types of subarrays where 1 is coming as minimum. Anything apart of this? No, everything is covered. So this is the formula I got. Next minimum of I minus I into I minus previous minimum of I. This much time my 1 is coming minimum. So while doing summation, I'll do this much times multiply by the value. Value is nothing but 1 in this case. Okay, 1 in this case. I hope you got my point. Now the only question is, they have not said that the elements are unique. Might be the example could be like this. So what? Then what? So the first 3, how many times the first 3 is coming as minimum? Okay, let me consider this example rather than this. Okay, how many times the 1 is coming? So for this particular 1, okay, 1 at index 1, I have said that 6 times it's coming. Okay, because next day, sorry, not here 6 time, it will be, let's count. Next minimum will be what? I, which is nothing but 5 over here, minus 1, so 5. And previous minimum is minus 1. So it is 5 minus 1 into 1 minus minus of 1, which is 5 twos are 10. So 10 times, sorry, 4 twos are 8. So 8 times this is coming. And which 8 subarrays? If I found this 8 subarrays, it's 3 1, 3 1 1, 1, 1 1. Not this, only this one wouldn't be considered in this case. Okay, because only this one will be for the position of 1 at index 2. It will be counted in that subarrays. Then 1 1 4 and 1 1 4 3. Okay, this is not 8, right? This is only 6. This is only 6. Why we have made it 8? Because I have considered the second one also. Otherwise it's only 8, right? 3 3 1 1. Okay, okay, it could be 3 1 1 4 and 3 1 1 4 3. Okay, oh, 8 are completed. Fine, fine. 8 is completed. So this I got as 8. Now if I have to find 1 at index 2, now I'm doing for 1 at index 2, this one. Okay, fine. Next minimum would be Same thing 5 and previous minimum would be minus 1. So here it will be 5 minus 2 because this current I is 2 into I minus previous of I. So I minus previous of I, which is 3. 5 minus 2, 3 into 3, which is 9. So this is saying that total 9 subarrays I could find. Is it true? I mean, okay, 311 could come, but 311 is here also. And 311 is here also. So which is true? This is the common subarrays. Okay, these are the common subarrays. So I cannot take 311 over here because I've counted it already for 1 at index 1. Okay, now this one couldn't be minimum. Any one of two ones could be minimum, not both, right? So if I have considered 8 subarrays for this, so the only thing left is the one at index 2, starting from index 2, then 143, 143, and then oh, nothing, right? Nothing. So only two subarrays. So what we need to find when we are doing this, any one of two, next minimum or previous minimum, we need to find the next minimum equal to or previous minimum equal to. That means that until now, what we are doing for the next minimum finding, we will traverse in the forward direction. Sorry, we will traverse in the backward direction. I is equal to n minus 1 till I greater than equal to 0, I minus minus. And then what are we doing? We are removing all elements greater than equal to current element, but we will remove only greater than elements, not greater than equal to. For any one of this we can do, either for next or for the previous. For previous we are removing, for previous we are doing it in the forward direction. It's just that simple case. For any of the next or previous, what we will do? We will do only greater than. So let's say for the next, we are doing greater than only and not greater than equal to. Okay. So now we need to find the next greater than or equal to minimum. So for the one next greater than or equal to minimum is at 2 index itself. Okay. So this would become 2 itself and not 5. And previous minimum is minus 1. So now this case will be like 2 minus 1 into 1 minus minus 1, which is 2 minus 1, 1, and this is 2. So only two subarrays will be considered here. Which two? 3, 1 and only 1. Other all have minimums of this second one. For the second one, next minimum is 5 because nothing is next minimum or equal to. Okay. And previous minimum is minus 1. Only one of the two we have to consider, either next or previous, where we have to consider equal to also. Okay. So what we need to find? We need to find next minimum or equal, find previous minimum, and then for every element sum plus equal to what? Next minimum equal of I minus I into, as we have to do it, sorry, oh why, okay, this we have to multiply by 1 ll, and then previous minimum of I minus previous minimum of I. Okay, this is the number of times, this is the number of times into our value, this is the sum, and whole we have to do modulo, this whole we have to do modulo m, which is given. Okay. Okay, so let me take one example and then we are done with it. So let's take this example itself. We have array is equal to 3, 1, 2, 4. Okay, fine. So now we need to find the two arrays, next minimum and next minimum equal and previous minimum. Let me take one also over here for a better understanding of next minimum equal. Okay, sorry. Fine. So now we need to find first the next minimum equal. Okay, I'll store the index only. So for 3 index will be 1. 1 is next minimum. For 1 next minimum equal is which index? This index. Okay, this index. So it will be 0 1 2 3 4, fourth index. For 2 its next minimum is again fourth index. For 4 also fourth index. For 1 nothing, minus 1, so it will be 5. Okay, and for the previous minimum, there we will not take equal, because one time we have to consider, not both the time. That's why for any one we will take equal. You can take previous minimum equal also and next minimum, that is also possible. Okay, for 3 it's nothing, so minus 1, no one is minimum. For 1 it's nothing, so minus 1. For 2 it's index 1. For 4 also it's index 1, and for 1 also it's index 1. No, not index 1. Previous minimum is no one, then 1, so minus 1, not equal we have to do over here. Okay, now we will have I is equal to 0 to n. Every time 3 multiply. First will be next minimum of I is 1 minus I, which is 0, into 0 minus minus 1. So 3 into 1 into 1, which is 3. Because 3, how many times 3 will be minimum? Only one time, which is this array, this subarray. No other subarray has 3 as minimum than this. Okay, now that come for 1. Let me write the array again over here. Okay, the 2, this also I would write it over here. 1 4 4 4 5, 1 4 4 4 5, and minus 1 minus 1 1 1 minus 1. Okay, now that comes for 1. So how many times this one will be minimum? So 4 minus 1 into 1 minus minus 1 times 1, which is 4 minus 1 3, into 2, which is 6 times. 6 times. Which are the 6 times? Should I write it? 3 1, only 1, 3 1 2, 3 1 2 4. Does 3 1 2 4 1 comes? No. There this one will come, because we have considered next minimum equal. Okay, 1 1 2 1 2 4. Right? 1 2 3 4 5 6 7. 7 times it was coming. I have taken this 1 2 times, so 6 times it's coming. Now that we have 2. So for 2 it's what? 4 minus index 2 into 2 minus index 1. 4 minus 2 2 into 1 2. So 2 2s are 4. 2 times only 2 is coming as minimum. Is it true? So it's only 2 and only 2 and 4. Right. Right? These are the only two subarrays. For 4, it should be only 4, as we know. Okay. So index is 0 1 2 3. 4 minus 3 into 3 minus 1. 4 minus 3, 1 into 2, 2. Oh, 2 times it's coming as minimum. No. Yeah. Previous minimum of 4 should be 2. So index 2 should come here, right? Okay. So this will be 2. So again, one time 4 is 4. Only 4 subarrays coming as minimum. And for this one, last one, next minimum is 5. So 5 minus 4 into 4 minus minus 1, which is 5 into 1. 5 times this one is coming as minimum. Which 5 times? Let's see. 3 1 2 4 1. This is 1. 1 2 4 1. This is 1. 2 4 1. 4 1. And only 1. These are the 5 different subarrays. I hope you got. And then we do the summation of all of this. Okay, let's just solve it. Okay, fine. So we have one constant m is equal to 1e9 plus 7. And now we have two vector of int. One is previous minimum. For previous minimum, we will make an array of size n. We'll move in forward direction, and we have one stack also. While not stack dot empty and array of stack dot top is we have to find the previous minimum. So we have to remove the greater ones. So y and array of stack dot top is greater than or equal to this current element, then we will remove it. If if not stack dot empty, previous of I is equal to stack dot top, stack dot push I, and we will return this previous array. Okay, the same thing happens for the, but that function we have to make is next minimum equal. Why? Because we are considering equal also in that case. So we will not remove the equal ones. Because we are considering, we will not remove the equal ones. This is the next array. This will be n minus 1 till 0. While not stack dot empty and it is greater than array of I, we will remove it, not equal to. If it is not empty, we will store as next of I is stack dot top and we will push I. And we will return the next. Okay. We have n as array dot size. Vector of int previous is equal to previous minimum of array. And vector of int next is equal to next minimum equal of array. Now we will move, we will have one sum of 0, sum plus equal to next minimum of I, next of I minus I into 1ll into I minus previous of I into 1ll into our current element, which is array of I. Sum modulo equal to m. Let me make this sum as long only as of now. Okay, and we will return this sum. What one thing we have to do is, if next of I is equal to minus 1, we will do next of I as n. I hope you got it. With the monotonic stack, this has become very easy and the time complexity has also reduced to order of n. Yes. Clear? We have another question which is quite similar to this. Okay. Let me just show you the question directly. So this says that you are given an integer array nums. The range of subarray of nums is the difference between the largest and smallest element in the subarray. This we have done previous question is only the summation of smallest elements of each subarray. This is the summation of differences of smallest minus largest. Largest minus smallest, sorry. And we have to return the sum of all subarray ranges of nums. So what we have to do over here, for every subarray, sum plus equal to maxi minus mini. Okay, so now what we have to do is, we have to find the number of times this element coming as maximum, find number of times array I coming as minimum. For that, what we have to do is, next minimum of I minus I into I minus previous minimum of I into value. This should be equal to 1, 1, 1, 1 should be equal to. And we have to find the number of times array I coming as maximum also. Okay, and that will be nothing but next max of I minus I into I minus previous max of I. So we need to write 4 different functions. Next minimum, previous minimum, next maximum equal to, and previous maximum into value. So now you got the number of times it is coming as maximum and number of times it is coming as minimum. Multiplied also with the value. Let's say this is A and this is B. What you have to do is sum plus equal to B minus A. Right? Right? Simple. I hope you can do that. So I'll post these two links over below in the question, and uh, this tab where we have learned on how to do this. So these are the subarray related problems where we have to do minimums of each subarrays, maximum of each subarrays, differences of max minus minimums of each subarrays, where each subarray is involved, and you need to check how you can do it with the optimal time complexity there where the monotonic stack is used. Okay, I hope you have learned a lot out of it. Do like, share, and subscribe it with your friends if you have learned a lot. And in the next video, I'll be going to cover some tricky questions of monotonic stack where you will get, okay, this is how we have to use monotonic stack. This is where we have to use the monotonic stacks. Okay, stay tuned for the next video. Stay tuned, stay safe. Bye bye.